Welcome back everyone. Today I'm going to talk about another topic that has to do with the knowledge of space and what is beyond the world that we see. Before we get started, please make sure to subscribe to my channel for my latest videos. How far can we travel? Is there a limit that we'll never cross? Are there places we'll never reach, no matter how hard we try? The hardest part is imagining the distances that spacecraft have to travel to reach other planets, such as Mars or asteroids. We can talk about tens of millions of kilometers, but the numbers are not enough to sense the feeling of isolation and loneliness that astronauts will endure during an interplanetary journey. People normally think of a time travel. How long will it take the Soyuz capsule to reach the International Space Station? Distance is probably the most relative concept in our connected world. The time required to get to a place now depends only on the availability of means of transport and money. We are in a quiet area of the Milky Way, a medium-sized spiral galaxy with a diameter of 100,000 light-years, containing billions of stars, clouds of gas, dark matter, black holes, neutron stars, and planets. Seen from afar, our galaxy looks dense, but in reality, it consists largely of empty space. On average, between two stars is a distance of 5 light-years. With current technology, it would take us thousands of years to reach the nearest star system. The Milky Way is quite large and not the only one. The Milky Way, together with the Andromeda Galaxy and about 30 other galaxies, including dwarf galaxies, form the local group, which is a region of space where galaxies are spread over a diameter of 100 million light-years. Our local group is one of the 100 groups in the Laniakea superswarm, which is just one of the millions of superswarms that make up the observable universe. Now, suppose for a moment that we have a bright future. Humanity becomes a Type 3 civilization, is not exterminated by aliens, and develops the technology needed for interstellar travel based on the current understandings of physics. In this scenario, at best, how far could we go? Well, we could only explore the local group. It is the largest structure that humanity will be part of. Although the local group is huge, it represents only 0.0000000.1% of the observable universe. The mere fact that there is actually a limit to us and that there are so many other galaxies that we'll never be able to reach is a little scary. Why can't we travel further? Well, everything has to do with the nature of nothing. Nothing, or empty space, is not empty, but has intrinsic energy, so-called quantum fluctuations. On a small scale, there is constant action, particle and antiparticles appearing and annihilating. You can imagine this quantum vacuum as bubbles, some with denser areas and others with less dense areas. Now, let's go back 13.8 billion years ago, when the structure of space consisted of nothing. Even after the Big Bang, in an event known as cosmic inflation, the observable universe expanded from the size of a ball to a diameter of trillions of kilometers in just a fraction of a second. This sudden expansion of the universe was so rapid and extreme that all quantum fluctuations were extended and the subatomic distances became galactic distances with an uneven density. After inflation, gravity began to attract matter. On a large scale, the expansion was too fast and strong to overcome gravity, but on a small scale, gravity gained, forming dense regions of matter, leading to the appearance of galaxies, like the one we live in today. Only the galaxies in the local group are gravitationally attracted. But can we leave the local group? Here, dark energy makes everything more complicated. 6 billion years ago, dark energy took control. It is responsible for the expansion of the universe. We do not know why or what is this energy, but we can clearly see its effect. Dark energy is responsible for the acceleration of the universe on a large scale. It causes the second derivative of the cosmic scale factor, a to p positive. But on a smaller scale, the agglomerations of matter in which the effect of the four forces, strong nuclear energy, weak nuclear energy, electromagnetism, and gravity, are much stronger than the repulsive effect of dark energy. In the early universe, there were larger, colder areas around the local group, from which clusters of thousands of galaxies appeared. We are surrounded by a lot of galaxies. These structures and galaxies outside the local group are not gravitationally related to us. The more the universe expands, the greater the distance. Over time, dark energy will push everything away from us, making all the other swarms of galaxies eventually untouchable. The closest group of galaxies is already millions of light years away, and is moving away from us at a speed we only dreamed of ever reaching. We could leave the local group to travel in intergalactic space in the dark, but we'll never get anywhere. As the universe expands further, the local group will shrink under the force of gravitational attraction. In a few billion years, the Andromeda galaxy will collide with the Milky Way and form a single giant galaxy called Milkdromeda. At some point, galaxies outside the local group will be so far away that the few photons that reach us will have such a long wavelength that they will no longer be detected. Once this happens, no information from outside the local group will be able to reach us. The universe will disappear in all directions, forever. A person born in the distant future in our galaxy will believe that there is nothing else in the universe outside of his galaxy. When they look far into the universe, they will see only emptiness and darkness. They will not be able to see cosmic radiation and will not be able to learn about the Big Bang. They will believe that the universe is static and eternal. Milkdromeda will be an island in the dark, getting darker and darker. However, there are trillions of stars in the local group, and it is large enough for mankind. After all, we have failed to leave our solar system and have enough time to explore the galaxy. Well, this was all for today, so if you liked my video, please make sure to subscribe to my channel and press the bell button to turn on the notifications for my latest videos. Thank you very much. See you next time.